I'm here to show you the moon. You've seen it before, but I'm here to show you that there's something wrong with it. This billiard ball is lighted from behind the camera, just as the moon is lighted from behind us when we see the full moon. Notice that toward the edge, the ball becomes darker and the edge is indistinct. Light that strikes the center of the ball gets scattered, but a lot of it comes straight back, so the center looks brightest. As we move away from the center, much of the light is scattered away, but still so much comes straight back that it still looks bright. But at the edge, most of the light is scattered behind the ball, so the edge looks dark and indistinct. But notice that the moon has a uniform brightness right up to the edge. How can this be? If the moon were flat, then no matter what angle the light strikes it, it will reflect back the same way, and the brightness will be uniform from one edge to the other. But the moon is not flat. Even if we hadn't sent spacecraft around the moon and photographed it from every conceivable angle, from the Earth we see the moon from slightly different angles in different parts of its orbit, and from these slight differences we can see that the moon is a sphere. What if the surface of the moon were covered with a material that always reflects light back the way it came from? In other words, what if the surface of the moon were retroreflective? If you place two mirrors at right angles to each other and shine a beam of light at them, the light will reflect back out the same way it came in. If you add a third mirror such that all three mirrors are at right angles to each other, this works in 3 dimensions. Since this forms the corner of a cube, this is called a corner cube retroreflector. Here this is done with metal plates to make a radar reflector. This is a group of these reflectors that will reflect radar from any direction. This is a corner cube glass prism used to reflect lasers for surveying, and of course here is a bicycle reflector which is molded with many corner cube reflectors. NASA left arrays of retroreflecting prisms on the moon, and these have been used to measure the distance between the Earth and the moon using lasers. But it takes a large telescope to receive back even a few photons from one of these arrays. But could there be a naturally occurring substance that could cover the moon and make its surface retroreflective? Well, it turns out that about 15% of the regolith that covers the moon consists of tiny glass spheres, much like these micrometeorites. A glass sphere by itself is not retroreflective. Light enters the sphere and is refracted, but eventually exits out the back. But if you put something behind the sphere, even just some dust that the sphere is mixed in with, then the light is reflected back into the sphere and goes back out the same direction it came in. Here I'm holding a glass sphere, illuminated the same way as the billiard ball was. Look what happens when I move my finger directly opposite. It becomes retroreflective. Here a road worker is sprinkling glass beads and a freshly painted arrow on the road. The driver's headlights will strike the paint, and much of the light is retroreflected back to the driver's eyes, making the paint much more visible. And since the lunar regolith has a significant number of glass spheres in it, the entire surface of the moon is retroreflective. You can see the retroreflectivity of the moon's surface in photographs taken by astronauts on the moon that include their own shadow. Notice the halo around the head of this astronaut in his shadow. This is because the sunlight passes the astronaut's head, strikes the moon, and much of it is reflected back into the camera, causing the bright area. This is the main reason why Buzz Aldrin is so brightly lit in this picture, even though he's in the shadow of the lunar module. Most of the light filling in the shadow is scattering and retroreflecting off the lunar surface. The rest is reflecting off of Neil Armstrong's spacesuit. So the moon, covered with these tiny glass spheres, reflects light back the way it came, and so to us appears bright, right up to the edge. Actually, the moon is populated by cats, and they're all looking at us.